All right, thank you. Welcome everybody, and thanks for joining this session. And this is how to build HTAP workloads, hybrid transactional analytical processing workloads using Azure Cosmos DB in Azure Synapse Link. That's my best American accent. Obviously, I'm not American. My name's Theo Van Cry. I'm a program manager in the Cosmos DB engineering team. If I was American, I'd be, asleep now, at least if I was American and a member of my team back at the ranch. So a little agenda for today. I want to talk about why we've created Synapse Link for Cosmos DB, how it works under the hood, how little does it cost, seriously, what are the typical scenarios, and some additional features and investments that we made recently as well. You probably will have questions. I'm going to ask you to hold them until the end. It's always possible that I may have answered them by the time we get to the end, but if not, happy to take them at the end. There should be probably 5-10 minutes or so at least for me to answer. So without further ado, before I talk about why we built it, I just wanted to set a little bit of context on Cosmos DB. If there's anybody there in the room who doesn't know what Cosmos DB is, or maybe you're not too familiar with it, you haven't worked with it that much, or the story behind it and so on, because this really sets the context for why we've built this, why this feature exists, this capability exists, and it kind of gives you an impression of why we needed to build it as well. So, of course, Cosmos DB, many of you will know, it's obviously built for high, massive scale, high throughput, high availability, low latency. It is characterized by these SLAs and certain aspects of the platform that are important to its users. But really, it is really built for massive scale. So if we just look at the kind of SLA side of the picture, really these days, even today, even though Cosmos DB has been around for nearly 5 years now in its current form, and obviously a lot longer than that internally at Microsoft, it's used by many of Microsoft's internal applications, certainly global scale applications. Even today, it's still one of the few services that is providing all of these SLAs across all of these performance dimensions. So we have a latency SLA, availability, throughput, and consistency, and so on. You'll find many cloud native operational database platforms will provide some of these, but very few will provide all of them. And you can see it's really built at the corner cases of these scenarios for high performance and high throughput. And I guess the point I'm getting across here is, if you're building a database that is stretching towards that end of the spectrum, the further away you're moving from something that's easy to provide an analytics layer for. Okay, obviously you're having multiple machines servicing atomic reads and writes at very high concurrency, and of course very high availability, low latency, and so on. You're providing guarantees on throughput and the consistency as well. Then it's going to be difficult to have the same layer, certainly providing you with a similarly effective analytics engine. And then if you also look at the app development side of it, of course, it's schemaless. Of course, it's not really schemaless. It's only schemaless at the database level. There's always a schema. It's just that responsibility is shifted into the app developer domain. So that has its advantages on the app developer side, obviously, with speed to market, agility, and so on. But then when you come to the analytics side and the analytics picture, you've got some challenges there, of course, with conformity and with consistency with respect to the data. And so, again, that brings with it challenges that our customers have faced, and especially those who are not only taking advantage of this, the schema flexibility, but also the high throughput, availability, low latency, and so on, becomes a real challenge, certainly from a customer perspective, to get a timely or any analytics in an easy and maintainable way. And so then when you look at the kinds of applications that it serves, I think you're probably starting to get the point now. Yeah, it's really serving a lot of mission critical services, especially in Microsoft Teams and Skype and Office 365 Live and Xbox Live and Active Directory and so on. Again, it's just, I'm really just repeating myself and making the same point. We're building a service that's really tilting very far in one end of a spectrum. And so to be using that same engine, that same capability for analytics is always going to be a bit of a challenge here. So, I mean, let's jump ahead here to what are the problems that we are solving or trying to solve here. So what we, what you generally have in any operational system, this isn't just true of Cosmos DB, it's true of SQL Server and SQL DB and any operational database. You're always going to have somebody coming along with a Python notebook or something that's going to want to get an aggregate view of some dimensions of the data that have been obviously modeled in an atomic way for your application. So that's going to clash with your performance predictions. And so you're going to get problems like impacting on operational workloads and the costs associated with that. It's very difficult to predict the impact that could have. And of course, traditionally, as most of you will know, the way that has been solved is to implement some kind of batch process. What do we call it? ETL. Yeah, that's the word. Yeah, to extract the data out at some point. Of course, inherently, the latency is high. Your data will be typically 24 hours out of date in that scenario. And of course, you need to build this and maintain this yourself. And over the years, that's evolved into more, let's say, flexible ways of doing this, like data lakes, where you have schema on read type paradigm, where you can query the data more easily. Perhaps you don't need to do as much upfront work in dimensional modeling and so on and so forth. But still, you have the same problem. You're not really fixing the underlying problem. You're just making it more manageable. You're shifting your sort of data movement problem into one corner and hoping that there's some point in the day, as it were, where there's not too much activity going on in your operational database. And then you can hopefully move that data safely without impacting your end customers or end users of the operational data. And so over time, of course, people have tried to come up with different architecture patterns to be able to get data in near real time without impacting the operational system too much. And so here we've got an example of a Lambda architecture and how it might apply to Cosmos DB. You'd push all your data into Cosmos DB for processing as normal. You'd have some kind of batch layer that's a master data set and is immutable. There'd be a serving layer that has batch views of the data for fast queries, and then the speed layer. And by the time I've got halfway through this, I'm almost tired just thinking about how long this would take to build and to maintain, and on all of the complexities associated with that. So along comes the analytical store in Cosmos DB. And so what this is a compressed column-oriented format that's co-located with the transactional store. It's synced in near real time. So within 2 minutes, every mutation in your transactional store will be available in the analytical store. And then this is surfaced through Synapse Link. So in Synapse, you can view this data with T-SQL or through Spark. And the benefit here at a very high level is there's no impact on your operational workloads. And that's probably if I were to pick out one thing to point out about this feature and about this capability, it's that the performance is isolated. So there's real true performance isolation. You don't need to worry about the movement of data from transactional to analytical and the complexities involved in that. That's completely transparent to the user. Once the data is available in the analytical store, your queries that you run there are not impacting your transactional store at any point throughout the day. There's no window that you need to wait for to move the data. There's no batch process. There's no need to build and maintain this yourself. And it's pretty low latency. In fact, we claim this is near real time. 2 minutes is probably good enough for most use cases. And as I will point out probably several times later on in the demos and so on, if you're doing things like group by and order by and sum and count and things like that, which we do provide in Cosmos DB, of course, it's not really designed to do that optimally. Even SQL Server and relational databases at some point, at some level of concurrency, at some level of throughput in your operational sort of map, if you like, a performance map, those types of queries you're going to struggle with them. So unless you really need to do that kind of thing to get the most up to the second view of the aggregate data, there's really no need to do this anymore, because there's this feature, and hopefully that will be made clear with some illustrations and a little demo later on. So you still have all of the advantages of a real-time, limitless operational NoSQL database. And maybe this is an important thing to point out. Well, I kind of pointed it out already. You have all of these features in Cosmos DB. They're all geared to at massive scale on the operational side. So you still have all of that, but now you have your data available and represented the way it looks in the operational store. Something I probably didn't mention earlier on. We maintain metadata in the analytical store so that although it's an immutable store, we represent the data as it appears in the transactional store. So from the perspective of the engine, the runtime engine that's querying the data, which is serviced through Synapse and via Synapse Link, it's as though you're just querying the Cosmos DB layer, but you're not actually impacting the transactional store itself. So yeah, what we're really trying to do here is break down this barrier between operational and analytical, OLTP and OLAP, if you like. And that's, of course, it's not anything new. This problem isn't a new problem. It's been a problem for probably 40, 50 years. As soon as we started doing analytics on operational data, we realized that there were differences in how you model data effectively for operational purposes versus analytical. So they're all, the easiest, most expedient way of companies solving that is that by having this hard line, this divide where the operational guys do their stuff, and then whatever problems that causes for analytical dimensions, some unlucky guy who's writing an ETL script somewhere in a landing zone and doing dimensional tables has to sort out. And what we're trying to do is kind of just break that down a little bit, cut out the middleman in terms of the movement of the data, and try and represent the operational data in its same form, but in a way that it can be queried and materialized in an analytical way using these different tools. So in summary, then, it's near real-time data analytics using the language that you prefer. Again, really key point, there's no performance impacts on your transactional workloads once the data is in the analytics store. Obviously, there's a cost reduction for BI and analytics workloads. Like I said before, if you're running these types of queries on Cosmos DB, it's going to be very expensive. It wasn't designed to do that. You're now storing it in a much cheaper format with much better compression, as you'll see later on. You can run those queries ad hoc instead of having to serve up enough compute to cope with both those types of queries and the ones that are happening in your operational space. And it's simplified as well. You could argue that you could build some kind of Lambda or Delta architecture or whatever. And those definitely have their purposes, and for certain discrete use cases, they might be necessary. But in a lot of cases, it is really reinventing the wheel in this discrete scenario, especially if your data is in Cosmos DB and you're wanting to do analytics on it. It's already been built. It's already there. The capability's there. Try it out. It probably will avoid you having to do a lot of complex stuff that you might otherwise be planning. So then, if you take a little bit of a closer look at the structure, then, as I mentioned, Cosmos DB, like every other operational database, is a transactional store. So the data is represented. The disk logical representation is by row. So when you're scanning and filtering out columns, you're scanning a lot of rows that you don't need. The analytical store is column oriented. So the logical representation there is by column. So when you're filtering by column, you're only getting the rows that you need for those columns. You're not scanning every single row's worth across all of the columns of data. So it works better for the analytical style queries that you might be running. Again, it's auto synced, so the data is synced from the transactional store to the analytical store within 2 minutes. It's self-managed compute, throughput, and storage without any downtime. So again, the process, the mechanisms involved in moving the data from transactional store to analytical store, completely transparent. You don't have to be concerned about that. And there's no performance cost. Again, we're repeating this a lot in these slides. No performance cost or monetary costs impacting your transactional workloads. That's a really important thing, especially for our customers that are hitting those corner cases where they're doing very, very high throughput. They need something like Cosmos DB for the operational side, but they also need non-trivial analytics as well. There's automatic schema inference. Of course, Cosmos DB is fundamentally a JSON-based data store. So this feature is currently available on SQL API and MongoDB, which are fundamentally the data model is document-oriented and JSON-based. So schema inference is important there. There are no data types as such, so you certainly need that feature. And then we have native integration with Azure Synapse, so it's exposed through Azure Synapse via Synapse Link, and you can analyze the data directly with T-SQL and Spark runtimes, as I will show a bit later on. And then Cosmos DB data, of course, many of you will know who know about Cosmos DB. It's a Ring 0 service. It's foundational in Azure. Anytime a data center is built, or Cosmos DB is present in that data center, and if it's present, it means all of its features are present, which includes analytics store. So it really is a global planet scale, if you like, way of having analytics materialize from a very high throughput operational database service. So yes, when your data is present in the analytics store, you can use all of the tools that you probably are all familiar with and you're all interested in. SQL serverless pools and dedicated SQL analytical T-SQL queries, near real-time dashboards. You get those endpoints, so they're compatible with Power BI and everything else that you know and love. And you can, it opens the door to building a logical data warehouse and those kind of composite views of different data stores as well. All right, so I'm just going to go through, it's not really a demo, I'm just going to go through slides showing how to enable Synapse Link here and enabling the analytics store container, and also creating a Synapse Link, a linked service with Azure Synapse. So this is your, for those of you who've not seen it, this would be your Cosmos DB Explorer. So you'd want to look for the Features tab, and then click on Synapse Link, and then just enable that. Or you could just go directly into the Data Explorer, and you'd see an Enable Azure Synapse Link right there. And you'd click on that, and either way, it's doing the same thing. So it's enabling Synapse Link for your Cosmos account. But you're not done there. So after that, you would need to make sure that when you're creating a container, that you are selecting analytical store for that container. Obviously, we don't want to automatically provision analytics store for every container. We don't want to assume that you want to propagate the data for everything, because obviously that has a performance overhead, albeit analytics store is much cheaper. You might not want to do that for some containers, so you'd have to explicitly select that for each container. And if you change your mind or you didn't select it and then you want to go back later, you've got the option of enabling existing containers as well. And so then we're still not done. So you need to go into Synapse Studio, and you would then be adding a new resource. And then you would select connect to external data, and you'd be looking for Cosmos DB. And then you would just select the account that you want to create the linked service for, and then you're done. And then you have a linked service that you can then use with all of the wonderful tools that you probably all are used to. So I'm going to do a quickish demo here of querying Cosmos DB container with a Synapse SQL serverless pull here. So first I'm going to go to, we'll look at a simple example first. So this is a Cosmos DB account, and this is Data Explorer, and I've got a few containers here. So it's something you can tell. Probably tell it's an IoT scenario. So I've got one container here that's called IoT signals, and the structure in each of these records is pretty flat. Well, it is flat, so there's no embedded JSON or any of that malarkey going on. And I've also got an IoT device info container where I'm storing information about each device that's produced all of these signals. So those of you who are astute and know about Cosmos DB might say, well, you could have modeled that differently. Maybe you could have modeled it like this, so that the information about each signal also contains the device info. That's also a possibility. But in this case, because this information is being updated frequently and there's an asymmetrical pattern between the updates of those two entities, I wanted to model them separately, and that would be a best practice. Those of you, I don't know if any of you attended my session yesterday, but I talked about data modeling and partitioning and best practices there. There's some trade-offs to be had, because of course you can't run joins between containers in Cosmos DB. We don't allow that. Again, I explained why yesterday. So in this case, I've got two separate containers because I'm really focused on high throughput and serving the requests, the atomic requests that I need ad hoc for that device information. But suppose I have an analytical requirement here and I want to get some aggregate counts, let's say, by certain dimensions within my signals and also within the device information itself. Well, I've got a bit of a challenge because I can't do joins. So I have to, well, what do? I have to pull the data out somewhere. So what I'm going to do here is, luckily, in both of these containers, as you'll see here, I've already got, I had enabled analytics store here. So all of this data is being propagated into my analytics store, and I'm going to connect to it from good old SQL Server Management Studio. There we go. So there's my endpoint. And so you could find this in your Synapse workspace by going to the overview, and you'll see there's a few endpoints that you can connect to. I'm using the SQL Serverless endpoint here. And so I've connected to that here in my SQL Server Management Studio. And from there, I can just write the queries that I want to write. So I've got, there's obviously a syntax to be able to connect to the object in the analytics store. But from there on in, I can do what I want to do. In this case, I want to join on my IoT device info, and I want to slice by some dimensions to get an aggregate count here of rows by those attributes that I've selected. And that's easy enough to do in here. And again, I'm probably going to sound like I'm repeating myself by the end of this, but once you have this capability, why would you try, even if you could do this, why would you try and do this in Cosmos DB? Why would you risk killing your performance and having to over provision and spending a lot of RUs and telling people that Cosmos DB is expensive when this capability is here and the storage is cheap and you can run it from the tools that you want to run it from? So that was that example. And now some of you will say to me, well, that's all very well, but you kind of cheated a bit because this was in a simple data structure. And we know, Theo, that there's all sorts of malarkey that people do in Cosmos DB with, embedded JSON like this and, denormalizing and all of that stupid stuff. So what do you do about that? And that's a good question. And of course, yes. Again, if you'd seen my session yesterday, refer you back to that. If you haven't, maybe you want to go and watch that video when it's out. You will have seen that what we ended up with there was a customer entity, which was structured like this, which had a denormalized address entity in there, an address array that was structured like this. And we also had another entity in the same container, which probably sounds completely loopy, but go and see the session and hopefully I've explained why that makes sense in the context of Cosmos DB. So our sales order entity here, again, we're filtering on a type parameter to get that entity because it's stored in the same container, and that has a details section, which is again the sales order details entity that would have been in the old AdventureWorks database or data set. So I've got yeah, an array of entities here. So that works in the operational scenario because for the requirements of that operational system, I just need to get back the details visibly, and I also just need to get back the customer. There's no need to aggregate any of this information. But suppose my requirement analytically is to get the total sales by country. Well, I've got a bit of a problem. That's going to be an annoying thing to do because, well, my country is in this embedded array here, and my sales information that I need, my price and my quantity, is in this embedded sales details section, which, yeah, it works on the operational side. And I'm sure those of you out there will be thinking back to horror shows that you've seen in the wild where people have been doing strange and weird operational stuff, and then it gets to the analytical side, and what do you do? So, well, what we do here is we go back to good old SQL Management Studio, and I've got a few queries here. Before I go through how we tackle that, I'm just going to run this query here. This is just selecting one record from my customer container with entity type customer, just to show you the value that comes back there. There's always a bit of an overhead with SQL serverless pools. There we go. So I've got a guy called Laurie Sands, and I'm going to go to my container here. That just happens to be the first record in the container, and I'm going to update this so that his last name is Van Cry, because he happens to be my brother. So I'll just update this, and then this, of course, as I said, this is all these containers also are enabled with Analytics Store in here. And so I expect to see this within 2 minutes in my Analytics Store. Now, it's potluck whether this is going to propagate straight away or not. Will it propagate, or will I have to wait for it? Who knows? What a thing to do for a live demo. Let's try it again. Eventually, it will be there. Shall I just keep trying it until it's there? No, I'm not going to do that. I'm going to carry on talking about what I was going to talk about. Eventually, we'll go back, and I can guarantee you that will have propagated into there. But let's look at the data structure that appears for these two entity types here, sales order and customer, in my customer container as it appears in the raw, if you like. And so you can see there, I've got the top level elements appearing fine, but then when anything that's embedded is you just get this gubbins here of an array of JSON documents, and equally with the sales order items, the line items for each order are being squashed into the details column there. So what I want to do is flatten those out so I can create a view for customers. And in that, I can use this cross-apply function with OpenJSON to flatten out that array and into I'm just selecting the country field here, and you can see I can cast those fields to data types if I wanted to make it easier to work with. And then also I can create another view called sales order details. And I'm going to do the same thing there, but with the details section, I'm going to flatten those out. So I'm going to end up getting a row for each of the line items in the order. So there's going to be multiple lines for the same order ID. And then so that I've already created those views. So if we look at the structure that we get then, hopefully it's what we expect and something that's a little bit easier to work with. And there we go. So I've got what I wanted here. I just got the country for each customer, and I've got the price and quantity, and of course, multiple line items for each order, but that's fine because all I want to do is the aggregate of price times quantity is sales from sales order details, and then I can join. I've got my joins back on customer ID in the sales order details view, and then I can group by country. And oh, how expensive that would be, even if you could do it on Cosmos DB, but we don't have to because this is not Cosmos DB. None of this is impacting the Cosmos DB platform at all. It's all in the analytics store, and it's using the T-SQL engine, and those views are just are maintained in there and stored in there. The metadata is stored in there, I should say. And so again, why would you do this in Cosmos DB when you can do it here? So that's it. I think that's it for that. And of course, you can also use Spark for this as well. You can do everything I just did there in Spark. I don't have a demo for this, but where you'd want to use Spark, of course, is if you need to do a little bit more manipulation than I had to do there on the data, and that might not necessarily be just because you're wanting to flatten out JSON structures. There might be other things that you need to do. There might be complex transformations that you want to do in between getting the data out. You might want to materialize some kind of extra dimension to the data. And of course, this is why Spark is popular, because it's more schema on read. You don't have to pre-prepare the data and be bottlenecked by the process of doing that. You can do that ad hoc. And of course, that has its trade-offs as well. It's not exactly simple to learn how to do that, but there's the capability to do that. And the bottom line is, like I've said loads of times now, whatever it is that you do when you're running it against the analytics store, it's not hitting Cosmos DB at all, but you're getting the data pretty much in near real time. So automatic schema inference, the main thing to point out here is that you either have the option of having what we call well-defined schema, which is just the first document that appears in the container defines the schema, and then any documents that have different property types, or that have property types with different data types. In other words, you know, first price appeared with a string and then it appeared with an integer. That will be ignored. So you want to make sure if you're selecting that option as a default, that your data is at least consistent in terms of data types, if not the data structures as well. In other words, the same data structures can appear as you got in your first document. If that's not the case, then you can use full fidelity schema, where we'll store something for each data type. So you can do a query a little bit like the one down there. I don't know if it's too small. Select price.float 64 from orders where status.string equals 1 as a string, or status.int 32 equals 1 as an integer. And you can, you can do that. Obviously, that has a little bit of a trade-off, because we're obviously storing a lot more information as metadata about the container. But if you've got, developers at the front end side who are always changing their data types, and you don't want to go over and hit them over the head with something heavy, then you've got this option of doing this. And obviously, hitting them over the head would be illegal in some states. So, yeah, there are some constraints. Obviously, there's always some constraints in a multi-tenanted system. Wouldn't be fun if there weren't. So you can only have a maximum of 1,000 properties across all nested levels in a document schema. There's a maximum nesting depth there. Properties in the first level of the document will be represented as columns, and as you saw in the demo earlier on, everything else will, if there's a nested, embedded, I should say, JSON or embedded arrays or multi-level arrays or multi-level document structures, then they'll just be squashed into the JSON and just be represented in that way. So you'll have to do some work to extract that out on the analytics side, on the Spark side or T-SQL. Property names in the document should be at the same level, should be unique when compared case insensitively. We do allow you to create properties at the same level in Cosmos DB that have the same name but have a different case. But if you were to do that, then you'd be violating a rule in the analytics store. So we wouldn't propagate those documents. Those elements. And I think, yeah, that's it for those. Properties value in different documents at the same level with the same name will be represented with the same column using the name format of the first instance. And that's just what I described there, basically. And so, of course, we have time to live in the analytics store for data retention. And typically what we see customers do is they will aggressively TTL their data on the Cosmos DB side, but then retain data for a little bit longer, however long they need it for their typical analytics lifecycle in Analytics Store. The default is that it will retain infinitely, but you obviously want to change that if you have a different policy there. And like I said, typically data remains hot for only a shorter period of time, typically in Cosmos DB. And then now you've got the freedom, since you have the data in the Analytics Store, if older data is typically queried less frequently, or usually when it is queried, it's more of an analytical query, then of course, you can just retain it for longer in the Analytics Store. And the benefit of doing that, I'm not going to do the demo because it's so straightforward. You can figure it out yourself in a couple of minutes. What I will talk about is a recent feature that we've added, allowing you to partition the Analytics Store. So you can add a mount with a partition store. And for very, very large data sets, so multi-terabyte data sets where you're always doing complete scans, even in a column-oriented store, this can kill performance. Again, it only kills performance on the analytics side. It doesn't do anything to Cosmos DB, but obviously you don't want to be waiting hours and hours for the response to certain queries. So you option partitioning the data there. And then, yeah, really an important point is the difference in pricing. Of course, Analytics Store is really priced very much in line with blob storage. This is what it's backed by. It's well over 10 times cheaper than the transactional store. There's a small charge, as there is in blob storage, with accessing it, but it's trivial compared to what you have to pay to access data in Cosmos DB, obviously, because we have solid state disks and we have compute and cores and memory needing to be serviced for accessing the data there. You don't have any of that in blob storage. And then, the Synapse Analytics runtimes, again, in comparison to RUs, I don't think it's quite comparable. And even if it were, the compression is significantly higher. So for every 5 terabytes of OLTP data, you're going to see about 1 terabyte in the Analytics Store there. So it's significantly cheaper. And as I was saying before, and probably repeating myself again, really, you really don't want to be doing, even though we have them, and in one sense that's the victim, the query engine in Cosmos DB is maybe a little bit of a victim of its own success, but we've provided some of those analytics or aggregate features, group by, order by, count, sum, and so on. And you can use them. And if you really need to get the most up to the minute view for that particular query, of course, you should use that. But if 2 minutes latency is fine, and there's really no excuse to be doing this directly on Cosmos DB. So some of the patterns then, we have for just your straightforward BI patterns, you've really got a choice between using Spark or Synapse or SQL, T-SQL. And we find most people are more comfortable with T-SQL. Obviously, they want the data unpacked in a tabular way, and they're used to that whole environment. When you get to the more machine learning type scenarios, of course, then Spark is going to come into its own then, particularly for prepping and training prediction pipelines. And like I was alluding to there, if you need to do more complex transformations of the data as it comes out in order to train machine learning models and then feed them back into the ML ops pipeline, into your transactional system for scoring and so on, then you're probably more likely to be using Spark, if not exclusively using it for those types of scenarios. So that was everything that I had. That we do have some samples, and definitely encourage you to go and look at this repo. The IoT stuff that I showed there is available in there, and we definitely welcome feedback on this feature and on the samples as well. And of course, it's been GA for a good while now. But what we found is that it seems to be still quite news to people when they find out that this exists, especially if they're used to building the types of pipelines that I was describing before. And that's it. But last but not least, please do grab your phone and scan the QR code or just click on the link that I'm going to show you here. And then hopefully I've got some time left for questions, which I'm happy to take.
You do, yeah. We've got about 10 minutes left. I know there are a handful in chat. Before I turn to those, are there any in the room? All right, hang on. Yeah.
So, two questions.
Okay.
First of all, most of customers, they already have a transactional store. So if I want to take advantage of the analytics store, I would need to move data from one container to the other, because the Synapse links will not read the transactional store. Is that correct? Is that a phase that I need to do?
Theo, could you hear that, or do you need me to say that back?
I think I just about heard it. So the question was, if you already have Cosmos DB and you have a container without analytics store enabled, do I need to migrate from one container to the other? Was that the question? Yeah,
Yes.
no, you can now enable analytics store on an existing container. And it will take some time to drain the container of the data and push it into analytics store, but you should be able to do that now on existing containers. So we've enabled that. It wasn't enabled from day one, but that should be possible now. I did show it in the demo at the beginning there.
Okay.
No data movement. And the second was, if you have analytics store with Synapse Link, will that generate extra cost for a serverless or a dedicated pool on Synapse?
Okay. Did you catch that?
Yes, and yeah, it's a great question. So you know, I've made the claim there that you have no cost on your transactional side in terms of RUs when you're querying the transactional store. I didn't mean to suggest that there was no cost on the analytics side for your analytics runtimes, but the point I was making there is you're not interfering with the transactional side, and you're not spending excessively, I would say, for running analytics queries. Of course, there will be a cost in running Spark and running T-SQL and SQL serverless pools, but that's a lot more manageable and a lot more flexible, because obviously they're serverless. So you know you're spending the overhead when you're running the query to bring up the compute that's needed to run the query. And the same with Spark, we have a on-demand capability there. We don't really have that in Cosmos DB. We do with serverless, but really serverless in Cosmos DB is for more discrete scenarios and I would say non-production scenarios at this point in terms of its cost effectiveness. It doesn't compare to having a serverless, a SQL serverless pool, or having a Spark pool that you can use on demand when you need to do your analytics. And even then, even if it were constant, the cost wouldn't be as high as if you were running those analytical queries on the transactional store by an order of magnitude, I would say, almost.
Okay. Good. Thanks. Any other questions from the room before we turn to the ones in chat? Okay. So what do we have in chat here? Okay. All right. So I've got 3. Hopefully we can squeeze all 3 in. So the first one is, can you access the column-oriented data other than through Synapse, e.g. using Azure Data Factory?
No, at this point, no. And I'm glad somebody asked that question. Today, it's only possible to access it through Synapse. So it's surfaced through Synapse. So it's a unique feature to Synapse. As to whether we will expose this in the future, watch this space. We certainly are thinking about that. Of course, it's not just an endpoint. I alluded to it briefly, but there's also some metadata involved and a kind of abstraction layer involved in making the data appear the way it appears in the transactional store. Remember, this is an append-only Parquet format back behind the scenes effectively. So it's not straightforward or trivial to make that appear in the same structure as it appears in the transactional store. But there are ways of exposing that as well, potentially in the future. So this is something that we're looking at. But the answer to your question is no. As of today, you can only access this, at least publicly, through Synapse. If you have a need to do that, however, I would say reach out to your account team, because we know that there are customers who are using things like, you know, Databricks and other platforms as well. They just want to access the raw blob storage, and they'll worry about the management of you know, what we're doing internally in Synapse to abstract away the complexity of presenting that view. But we can enable that if necessary. But right now, it's not a public feature. No.
Okay. Second to last question is, do you have any plans to support Schema inference for JSON array document fields? For example, auto-generating views to flatten the denormalized document record in SQL Server lists.
That is a great suggestion. I don't know, because I don't work directly on Synapse Link and Analytics Store. I believe we do have a plan for that. It's not very near, I don't think, but I'd have to check on that. I don't know the answer to that. I'd love to get whoever it was can feel free to reach out to me, and I'll update you when I know the answer to that. It's a good question. I think it's a nice feature, a great feature to add. Not terribly trivial, but it's a good question. I don't know the answer, but I believe we do have a plan for it.
Okay. And the last one we have is, can Synapse Link maintain a history of Cosmos document versions? Notes that this is a common pattern in more traditional ETL approaches.
Yeah, so well, effectively, it is keeping a history of those versions. So the storage layer underneath is we just have a stripe of blob storage accounts, basically. So there is the capability to do time travel queries. We just haven't surfaced that capability yet in the Synapse layer. So there is the architecture, if you like, the backbone to do that. We just haven't serviced the feature or built the you know, the abstraction, the interface to allow you to do that. I don't know if I answered the question or not.
Yeah, I think we're good. I don't see any other hands. So really nice job. There's tons of cool stuff in there. But I think I will turn the mic off, and I think we're all through. Thank you so much.
Awesome. Yeah, thanks everyone. And please try out Synapse Link if you haven't already.